Greetings, Char, and this is Mr. Caslin. I wanted to go over a geometry problem with you. I think it was number 6 that was in the SAT packet. When we looked at it briefly, the solution wasn't obvious to me, so I thought I'd study it a little and maybe give you the best method. So this is what I came up with. We're looking for the area of the overlapping piece of these two circles. Okay, most of it we can quickly get just by realizing if this is the center of the circle, then this is a sector area, all this yellow. You're gonna have to forgive me today. I'm writing on a surface. It's really hard to write with a mouse, so you'll have to forgive me. Anyway, so this yellow piece, and I don't mean to include those outer edges. All right, so it's just the inside. Okay, so that area we can come up with pretty quickly because that's a sector area. We have a radius of 6. So r squared is 36. So pi r squared would be the whole circle, and we want just this proportion. Well, this is an equilateral triangle. Okay, so this is going to be 60 degrees. This is going to be another 60, so 120 altogether. These are 30, 60, 90 triangles. Okay, so from here to here is going to be 120 over 360, so you've gone around 1/3 of your circle. Okay, so 36 divided by 3. The area of that yellow region is 12 pi. So that's the easy part. Okay, now we have to add to it these two little pieces, and I thought that was the tricky part. We're gonna add to it those two pieces. We don't know what that is yet. Wow, this writing tool is really not good. So bear with me. All right, I'm just putting this box. We're going to fill in the answer when we get it. So, to get two of these outside pieces, think of it as we could do our sector area again and subtract out the parallelogram, and then we would get two of these. So we're going to take our yellow area, and then we're going to take the yellow area again. We're going to subtract out this parallelogram, which we'll call this pinkish area. And we should be left with the blue area, and so we're going to add in that blue area. Okay, hope this is an interesting problem. Hopefully my explanation is good. So instead of an area of a parallelogram, I'm going to break this up into two triangles. All right, so I'm going to do this large triangle on the right hand side. So 1/2 base times height, 1/2. All right, so one thing we do know is, remember, the radius of the circle is 6. They gave us that. This is a 30, 60, 90. So if your hypotenuse is 6, your short leg is half of that, which is 3. And your long leg is 3 times the square root of 3. Okay. So this big triangle on the right hand side is going to be, the base is going to be 3 square root of 3 plus another 3 square root of 3, which is 6 root 3. Okay, and then the height is this piece, which is times 3. Okay, now that was what I just did, was the area of, oh, excuse me, it's the area of this triangle. Well, to get the area of the parallelogram, we're going to double that. Since we have 1/2 here, we're going to multiply by 2, get rid of that. So the area of the entire parallelogram is now going to be basically 18 square root of 3. Okay, So remember, to get this piece here and this piece here, we were going to take our yellow area, subtract out the parallelogram. So we're going to subtract out 18 root 3. So add these together. We're adding the yellow area, 12 pi. And then 12 pi minus 18 root 3. So we're going to get 24. Whoops, wrong one. Back. 24 minus 18 root 3, which was answer C. Okay, pretty challenging SAT question. We didn't have a direct formula for the overlapping area of two circles. Maybe there's some wizard mathematician that has that, but I don't know what that is, so we had to break this out into pieces. I hope this helps. We will talk to you later. Thanks.